good morning. Let's go over the review from the weekend. So with number 10 and number 12, we're looking to see if it's a growth or decay, and then to find the y-intercept. So in this first one, the b value that's being raised to the x is greater than 1, so this is a growth. And your y-intercept is your a value. So you're always going to have 0, and then whatever this a value is in front, which is 25/7. In the second one, number 12, this b value is less than 1. It's between 0 and 1. And so this is a decay. And your y-intercept is at 0, and again, the a value, 2.25. Moving to number 14. For number 14, it says a $12,500 car depreciates at 9% each year. And they want you to find the value after 5 years. So we have y equals your initial amount, which is $12,500, parentheses. Since it depreciates, it's 1 minus, and 9% is a decimal, is 0.09. We're going to raise that to the 5th power. So if you plug that into your calculator, you should get $7,800.40. In the next section, number 16, it says, how does the graph of the function compare to the parent function? For number 16, we have y equals 5 times 2 to the x plus 1 plus 3. So first we begin with looking at the exponent, which there is an x plus 1. If we set that equal to 0 and solve it, or if we remember that it's just opposite, we know that we are going to the left 1. And our final number, our k value, means we go up 3. Number 18. For number 18, it says find the amount in a continuously compounded account for the given condition. Compounded continuously is the equation A equals P, P is principal, e to the RT. Now, we only use this one time, and I talked us through it. I'm going to talk you through this one as well, because again, we're only using it once. So, it tells us in 18 that the principal is $1,000. E, our R value is 4.8%. So, as a decimal, that's 0.048, and times T, which is 2. So for number 18, the correct answer is $1,100.76. All right, number 20 and 22, you are just plugging into your calculator. So for number 20, e to the negative 3, remember in your calculator, that's the second button and using your natural log key. So when you plug in that one, you get 0.0498. For number 22, again, you are just plugging in your e value, e to the 5th power, and that is 148.4132. So moving into the next section, with number 24. For 24 and 26, you are rewriting the equation in log form. So 24 starts off as 6 to the 2nd power equals 36. Rewriting that in log form, you have log. Remember, the base to your exponent is the base of your log of 36 equals your exponent. For number 26, we have 3 to the 3rd power equals 27. So we start with log. The base to your exponent, the base of your log of 27 equals your exponent. Number 28, we are writing it in the other form, or we're evaluating the log. We have log base 2 of 64. Now, we can do this a couple different ways. Option number 1 is we set this equal to x, change it into exponential form, so 2 to the x equals 64. Now get the same base, so 2 to the x equals 2. And again, if you break down 64, it's 2 to the 6th power, and so then this is a 1-to-1 function, and x equals 6. The other option is when you have log base 2 of 64 is to use our properties. We can do log base 2 of 2 to the 6th. Remember that when you have an exponent, that gets to go out in front and become your coefficient. So I have 6 log base 2 of 2, and log base 2 of 2 is equal to 1. So we just get 6. Either way works. Number 30, we have log 0.0000. Make sure I count the zeros right. 1. All right, so first of all, if we were to change this, we can rewrite this as log. Now when there's no base here, remember that's base 10, and this is 10 to the negative 5 power. So again, this negative 5 exponent can come out in front. So we have negative 5 log base 10 of 10. And of course, log base 10 of 10 is equal to 1. So I have negative 5 times 1, or negative 5. Number 32, we were graphing. For number 32, we have y equals log base 3 of x. To graph it, there are 2 points your log function should go through. The first one is always the point 1, 0. The second one is your base point, which is at 3, 1. And it approaches your asymptote in this case, which is the y-axis. Number 34, we have y equals 3 log base 2 of x. Now 3 is a stretch, right? And we've talked about this. Again, it should go through the point 1, 0. And then, of course, the base point is a 2, so that's 2, 1. And this actually stretches up this direction, but again, approaches the asymptote at y equals 0. For number 36, we have y equals 3 log base 4 of x plus 1. And here we just want to know, how does it compare to the parent function? What is happening in number 36? Well, first of all, this 3 in front we just mentioned was a stretch of 3. And of course, in with x, this, if you set it equal to 0 and solve it, you get that this goes to the left 1. All right, moving into the next section, 7.4. Number 38, we have log 8 plus log 3. In the log world, when we are adding, we are multiplying. So this is simply log 24. Number 40, I have 4 log base 3 of x plus log base 3 of 7. I want to remind you, if we have a coefficient, this coefficient is always the exponent. So I have log base 3 of x to the 4th plus log base 3 of 7. And again, in the log world, when we're adding, we're really multiplying. So we have log base 3 of 7 x to the 4th. So again, we always want our coefficient to come before our variable. Number 42. For number 42, we have log 5 minus 2 log x. Again, this coefficient is actually the exponent. So I have log 5 minus log x to the second. And in the log world, when we're subtracting, we're really dividing. So I have log 5 over x squared. All right, number 44. For number 44, we're going to actually expand this one. So I have log base 4 of x squared plus y to the third. Oop, not plus y to the third, sorry. I wrote that incorrectly. X squared y to the third. There we go. Now, in the log world, when we're multiplying, we're really adding. So we have log base 4 of x squared plus log base 4 of y to the third. Then the opposite of what we were doing on problem number 42, we actually have to take our exponents and move them to the coefficients. So our final answer would be 2 log base 4 of x plus 3 log base 4 of y. Number 46. For 46, we have log base 3 of 2 over x. All right, and in the log world, when we're dividing, we're really subtracting. So this is the log base 3 of 2 minus the log base 3 of x. Number 48. For number 48, we have log base 2 of 2y minus 4 to the third power. All right, so for this one, there's only one thing we can really do here. Actually, there's two. So here's one. We can move our coefficient to the front. So we have 3 log base 2 of 2y minus 4. Now, usually when it's all grouped with a parenthesis, we can't separate it. But you might notice there's something we can undistribute here. I have 3 log base 2 of 2 times y minus 2, which means in the log world, we're actually adding. So I have 3 log base 2 of 2 plus 3 log base 2 of y minus 2. Now, last thing we can talk about here is option number 3. What does this give us? That is equal to 1. So 3 times 1 is 3 plus 3 log base 2 of y minus 2. This is fully expanded. We don't typically worry about factoring things out, but it is possible. All right, number 50. For number 50, we are doing the change of base formula. We have log base 2 of 7. So by the change of base formula, you type in log 7 and divide by log 2. And in your calculator, if you type it correctly, you should get approximately 2.1. All right, moving to number 52. This is where we get to start solving. Number 52, we start off with 25 to the 2x equals 125. If we get the same base here in order to solve, 25 is actually 5 squared times by your exponent that's already there. And 125 is actually 5 to the third power. So since this is a one-to-one function, we can set our exponents equal to each other. So 2 times 2x is 4x, and that equals 3. divide both sides by 4. And we get x equals 3 over 4, or 0.75 is okay also. 54, I have 7 to the x minus 3 equals 25. So on this one, there's no way to get the similar bases to do a one-to-one function, so we have to change this into log form. So this is log base 7 of 25 equals x minus 3. So then we put in our calculator. On this side, we get 2.9299 equals x minus 3. And of course, then we're going to add 3 to both sides. So we get x equals 5.9299. Number 56. Number 56, we have log 3x equals 1. All right, in this one, to get rid of log, since the log term is already by itself, we need to change it to exponential. When there is no base, that means that base is 10. So we take 10 to the first power equals 3x. So we have 10 equals 3x, and of course divide both sides by 3. And we get x equals 10/3, or you can say 3.3 repeating. Number 58. For number 58, I have log x equals log 2x squared minus 2. So I'm going to start by moving my log over to the other side. So I'm going to subtract my log 2x squared to the other side. So here I have log x minus log 2x squared equals negative 2. In the log world, remember we can divide. So this is really log of x over 2x squared equals negative 2. Well, this can actually reduce. Our x's can cancel. So this becomes log 1 over 2x equals negative 2. Now, to get rid of the base, or to get rid of the log, we have to do our base. And again, when there's no base there, it is 10. So I have 10 to the negative 2 equals 1 over 2x. A couple different ways we can solve this one. 10 to the negative 2, if I put it in decimal land, is 0.01. Or I can write this as 1 over 100 equals 1 over 2x. Now if I go ahead and cross multiply, I get 2x equals 100. Divide both sides by 2, and we get x equals 50. All right, number 60. For number 60, we have 5 to the 2x equals 20. So it says to solve it by graphing. So you could graph both of them and find out where they intersect. Or we can just do it by algebraically. It doesn't matter to me which way you choose to do it. Algebraically, we would change this into log form. So I have log, the base of the exponent is the base of my log, of 20 equals 2x. So I go to my calculator. On the left, I get 1.8613 equals 2x. And of course, I would divide both sides by 2. So I get x equals 0.9306. Number 62. For number 62, we have 6 to the 3x plus 1 equals 215. So again, I need to change this into log. So this is log base 6 of 215 equals 3x plus 1. Going to my calculator. On the left, I get 2.9974 equals 3x plus 1. Subtract 1 from both sides. I have 1.9974 equals 3x. And then divide both sides by 3. And we get x equals 0.6658. Number 64. Now, this is a word problem, so I'm sure there's a few questions. It says a culture of 10 bacteria is started, and the number of bacteria will double every hour. In about how many hours will there be 3 million bacteria? So first of all, our starting amount, we have 10 bacteria. It is doubling, so that's a factor of 2, but we don't know how many hours. So we're going to set this equal to 3 million. All right, now we have to solve for x. The first thing we're going to do is divide both sides by 10, which cancels out to 0. So I have 300,000 equals 2 to the x. Now I have to change something that's an exponential into log in order to solve for x. So this is log, the base of my exponent is the base of my log of 300,000 equals x. So I grab my calculator. And I put in, on this one I get, for number 64, about 18.19 or 2 hours. Number 66. This is the last section we were working with. For number 66, we have the natural log of x plus the natural log of x plus 1 equals 2. In the log world, the natural log world is exactly the same. When we add, we really multiply. So I have the natural log of x times x plus 1 equals 2. To get rid of natural log, I have to raise it from the base of e. E and natural log cancel. So on this side, I have x times x plus 1 equals, I go to my calculator, type in e to the second power, and I get 7.389. All right, so if I go ahead and distribute my x, I get x squared plus x. I can subtract that to the other side, so minus 7.389 equals 0. Now there's lots of ways in order to solve this one. Now I personally would probably graph it and see where it crosses the x-axis and find it that way. So for number 66, we actually get 2 answers, but one of them is negative, and we cannot plug in a negative answer in for x. So the second answer, which is negative, is extraneous. So we get 2.26. Or you could do the quadratic formula. 68. Number 68, I have the natural log of 4 minus the natural log of x equals 2. Again, in the log world, when we subtract, we really divide. So I have the natural log of 4 over x equals 2. To get rid of natural log, I have to raise it from e. E and natural log cancel. So I have 4 over x equals, e to the second is 7.389. Now I would cross multiply, so I get 4 equals 7.389x, and then divide by 7.389 to both sides. And we get x equals approximately 0.54. And our last one today, number 70. For number 70, we have 3 natural log x plus natural log 5 equals 7. Again, we're going to go ahead and move this 3 to the x. So I have the natural log of x to the third plus the natural log of 5 equals 7. In the log world, when we add, we really multiply. So that's the natural log of 5x to the third equals 7. To get rid of natural log, again, we take it from e. E and natural log cancel. I have 5x to the third equals, in my calculator, e to the 7th power is equal to 1,096.633. Then divide both sides by 5. We get x to the third equals 219.3266. And then to get rid of the third, we have to either cube root or take it to the 1/3 power. And we get x equals approximately 6.0306. All right. Make sure that you are understanding each and every one of these for tomorrow's test. Next, you will have a quizzes to do, and of course, don't forget, you need to submit your work, and your notes are due tomorrow. Good luck.